Bismillahirrahmanirrahim. Assalamu alaikum. The topic of the lecture is the water soluble vitamins, and today we discuss the vitamin B2 or the riboflavin. Riboflavin or the vitamin B2, it is also the water soluble vitamin. Riboflavin or vitamin B2 is heat stable, it is light sensitive. It is the redox vitamin because its coenzyme form or the active form involved in the oxidation reduction reaction. The storage form of the vitamin B2 in the liver is the FAD flavin adenine dinucleotide. Because of its intense yellow color, it is widely used as a food additive. Sources are liver, kidney, dairy products, and the outer layer of the cereals are the rich source of the vitamin B2. RDA 1 to 1.5 milligram. Structure or chemistry of the riboflavin. Chemically, riboflavin is dimethyl-ribitol isoalloxazine, consisting of an isoalloxazine ring, which is also called as the flavin nucleus, with the ribitol side chain. Ribitol is an alcohol derived from the ribose. The isoalloxazine ring is attached to the ribitol side chain through its nitrogen atom. Isoalloxazine attached with the ribitol is called as the riboflavin, while N-phosphate is attached to the riboflavin. It is called as the FMN flavin mononucleotide, and FAD, that is the flavin adenine dinucleotide, is formed when the adenosine monophosphate moiety transferred from ATP to the FM. Coenzyme form or the active form of the riboflavin. Riboflavin is a component of the two coenzymes flavin mononucleotide, also called as the FMN, and the flavin adenine dinucleotide called the FAD. Both of they are known as the flavin nucleotides. Structure, here is the structure of the riboflavin, FAD and FMN. Riboflavin, this is the ribitol side chain, and this is the structure of isoalloxazine ring. Here ring A, B and C. A is called as the pyrimidine ring, azine ring and the benzene. The isoalloxazine ring attached to its nitrogen atom to the ribitol side chain, and this structure is called as the riboflavin or vitamin B2. When the phosphate moiety is attached, phosphate group is attached to the riboflavin, it is called as the FMN flavin mononucleotide, while FAD, which contains adenosine linked via phosphate group to the FMN, is formed by the adenylation. Here is the conversion of the riboflavin into the FMN and FAD. The two biological active form of the B2 are the flavin mononucleotide and flavin adenine dinucleotide, formed by the transfer of an adenosine monophosphate moiety from ATP to the FMN. The flavin nucleotides serve as a prosthetic group for the enzymes called the flavin-dependent enzymes, or you can say flavoprotein. These enzymes remove a pair of the hydrogen atom from the substrate and thereby participate in the number of the oxidation and reduction reaction in the metabolism. Absorption, transport and storage. Riboflavin is ingested in the form of the flavoproteins. The FAD and FMN components are released from the protein complex in the stomach, and free riboflavin is released in the intestine, from which it is absorbed by an active ATP dependent process. The activation of the riboflavin by an ATP-dependent enzyme system occurs, resulting in the production of the FAD and FMN, the main storage form of the vitamin and found mainly in the liver is the FAD. Here is the synthesis of FMN and FAD from the dietary riboflavin. FMN is formed in the intestine by the attachment of the phosphate group to the ribitol side chain. FAD, which contains adenosine linked via phosphate group to FMN, and it is formed by the adenylation of later in the liver. Functions. The function of the riboflavin all exerted by its coenzyme form, that is the FAD and FMN. Flavin coenzymes are electron carrier in the oxidoreduction reactions. For example, ETC, electron transport chain. It acts as a coenzyme for a key enzyme in the fatty acid and amino acid oxidation, also in the citric acid cycle. They are also as a coenzyme for the enzyme acyl-CoA dehydrogenase, amino acid oxidase, succinate dehydrogenase. The flavin nucleotides serve as a prosthetic group for the enzyme called the flavoproteins or the flavin-dependent enzymes. FMN and FAD are each capable of reversibly accepting two hydrogen atoms, forming FMNH2 or FADH2. FMN and FAD are bound tightly, sometimes covalently, to the flavoenzymes, and that catalyze the oxidation or reduction of the substrate. FMN dependent enzymes. The enzymes which use the FMN as a coenzymes are the L-amino acid oxidase and NADH dehydrogenase in the respiratory chain, while the enzymes which use FAD as a coenzyme are the microsomal hydroxylase system. They are the constituent of the complex 2 of the respiratory chain. They are also the constituents of the various enzymes, for example, D-amino acid oxidase, succinate dehydrogenase, acyl-CoA dehydrogenase, glycerol 3-phosphate dehydrogenase, xanthine oxidase, pyruvate dehydrogenase, and alpha-ketoglutarate dehydrogenase. These are the examples of the enzymes which use the FAD as a coenzyme. FAD is a coenzyme to the glutathione reductase in the regeneration of the reduced glutathione from oxidized glutathione. However, riboflavin has a role pro-oxidative and antioxidant. Because flavin also has both functions, because oxidative stress is due to its ability to produce superoxide to catalyze the production of hydrogen peroxide, and its role as an antioxidant is due to that, because riboflavin is one of the neglected antioxidant nutrients that may have an antioxidant action either independently or as a component of the glutathione redox cycle. FAD is coenzyme of the glutathione reductase in regeneration of reduced glutathione from oxidized glutathione, and it is necessary for the removal of the lipid peroxide. Deficiency. Riboflavin deficiency is widespread, but it is not fatal. It is not associated with the major human disease, although it is frequently accompanies with the deficiency of the other vitamins. Due to the efficient conservation of the tissues, riboflavin released by the catabolism of the enzyme is rapidly incorporated into newly synthesized enzyme. Due to this deficiency is not fatal, or this deficiency is real. Deficiency is of the riboflavin is characterized by the chlorosis, inflammation of the tongue, seborrheic dermatitis, glossitis. All these condition is referred to as riboflavinosis. However, the symptoms of the arabiclavinosis are relatively mild and certainly not life-threatening. There are two main reasons for this. One is that riboflavin is associated with the protein in the diet, and any diet providing protein will also provide a fair amount of the riboflavin. The other reason is that recycling of the riboflavin released from FAD and FMN is extremely efficient, and therefore only small amounts need to be ingested. So the deficiency of riboflavin is rare. Nutritional status: glutathione reductase used as index of the riboflavin status. As the riboflavin is the light sensitive, phototherapy for the hypercholesterolemia may require supplementation with the vitamin.